Today we're doing Module 4, Lesson 3, where we're continuing to look at interpreting fraction as a division. So as a review, yesterday we were doing problems like 8 divided by 3. And we practiced how that would really be 8 crackers divided and shared by 3 people. So if I was going to draw my 8 crackers, and I'm sharing them with 3 people, I need to distribute those crackers. And so there were 2 ways we looked at doing that. One way is I could distribute all the wholes first, and then I could break up the pieces, or I could break up all of these pieces and then distribute them that way. So if I was going to break all of these pieces up, I would break them into thirds because each person is getting 1/3 of the cracker. So now if I counted all of these, I have 24 thirds because I have 3 in every of my 8 crackers, and 8 times 3 is 24. So I have 24 thirds. I'm taking these 24 thirds and I'm dividing it by 3. Well, 24 divided by 3 is 8. So that means each person is going to get 8 of these little third pieces, etc., which is really 8 thirds. So each person gets 8 third pieces, so 8 thirds. And another way of writing that, because I can take out 2 wholes and then I have 2 left over, is each person would get 2 and 2 thirds. This would have worked as well if I thought about them in full groups, where like this person gets this whole cracker, this person gets this whole cracker. If I distributed them out by whole crackers, each person would get 2 full crackers, and then I would have these 2 crackers left to split, which means that each person would end up with 2 thirds. So either way you look at it, you're going to end up with each person getting 2 thirds, because 8 divided by 3 is really 8 over 3, which equals 2 and 2 thirds. So let's practice that on the next page. So we're going to fill in this chart. This first one is done for us, so it gives us an idea. So we're looking at the division expression, writing it in unit form, writing it as an improper fraction, and we use the term fraction greater than 1 instead of improper fraction. They mean the same thing. Mixed numbers, and then the standard algorithm. So for B, they gave us the mixed number, which is 1 2/5. I can go from a mixed number to an improper fraction by thinking, okay, 1 2/5. This 1 I can think of as 5/5 and 2/5. So if I combine those together, I can get 7/5. So I can go from 1 2/5 is the same thing as saying 7/5. You see how I did that by I took that 1 and I turned it into a 5/5? You can also do it. The shorthand of that is if you take the 5 and you multiply it by the 1 and then you add the 2 and you get 7/5. So now that I have my improper fraction, 7/5, I know what division statement that is because we practiced that yesterday. This is 7 divided by 5, because remember that fraction bar is just a division sign. So it's 7 divided by 5. And I can solve that 7 divided by 5 using standard algorithm, 7 divided by 5. And I can solve this standard algorithm problem. 5 goes into 7 one whole time. 1 times 5 is 5. And we get 2 left over. So we're left over with 2/5 as our fraction. So we get 1 2/5, which is the same thing as the mixed number. So we're kind of seeing how they're all connected. The last one we have to do is the unit form. That's when we're thinking about crackers. So we think about our 7 crackers. 3, 4, 5, 6. And I have 7 crackers, and I'm breaking each cracker into fifths. Unit form is how many pieces do I have right now? Well, I have 35 pieces. I have 35 fifths, and I'm dividing it by 5 because I'm putting it into 5 groups. So I'm putting it into like 5 circles. Well, 35 fifths divided by 5 is going to give me 7 fifths. So I can fill this in. 35 fifths divided by 5 gives me 7 fifths. So we're able to kind of like go from one piece on our chart and fill out all the missing components. Let's practice it one more. This time, they gave us the standard algorithm to start with. So it's 7 divided by 2. So right away, I can do this one, 7 divided by 2, because I just said it. 7 divided by 2 is my division expression. 7 divided by 2, I can go and make my improper fraction because I know that 7 divided by 2 can be written as 7 over 2. The first number becomes the numerator, the second number becomes the denominator. To find the mixed number, I'm going to solve the standard algorithm here. 2 goes into 7 3 times. 3 times 2 is 6. Subtract and we get 1. So we get 7 minus 6 is 1. Now I have my fraction remainder is 1 out of 2 pieces. So I get 3 halves as my mixed number, which you might have been able to see just by looking at 7 halves. How many 2 halves can you take out? But I also still like to do the standard algorithm. Last one is the unit form. And that's when I'm looking at how many total halves do I have in 7. So instead I'm going to picture my crackers in my head. If I have 7 crackers and I split them all into half, how many halves do I have? Well, 7 times 2 is 14. So I have 14 halves because each of my 7 crackers is going to be split into 2. And so 14 halves divided by 2 is going to give me 7 halves as my answer. So the purpose of this is just to see how these are all connected to each other and how you can go from one to the other. Let's practice this with a formal problem here. Polly buys 14 cupcakes for a party. The bakery puts them into boxes that hold 4 cupcakes each. Okay, so she has 14 total cupcakes, and each box holds 4. How many boxes will be needed for Polly to bring all the cupcakes to the party? So if we have 14 cupcakes, so I'm going to draw them out. 6, 7, 8, 9, 10, 11, 12, 13, 14, woo! And I'm putting them into boxes. Each box can hold 4. And they want to know how many boxes will be needed for Polly to bring the cupcakes. So that means each of my boxes holds 4. So I have 1 whole box, 2 whole box, 3 boxes, and then I have these 4 cupcakes. So I have to send those cupcakes too. I can't just ignore those cupcakes. So I'm going to need another box, even though it could hold extra cupcakes. It's going to be half filled, but I'll have 4 boxes. We solved this doing a drawing, but if I was going to do this as a division, what I just did is I did 14 divided by 4. I have 14 cupcakes. I'm putting them in 4 groups. So 14 divided by 4. 4 goes into 14 3 times to get 12 with 2 as a remainder. Well, I need to deal with those 2 as a remainder. So really, this becomes 4 boxes. I needed to round up thinking about my remainder. Question B, if the bakery completely fills as many boxes as possible, what fraction of the last box is empty? So let's look at this for a second. If the bakery completely fills as many as possible, what fraction of the last box is empty? How many more cupcakes are needed to fill this box? Okay, well, we already kind of drew this out. We kind of did this already, which is great. We drew the boxes. We were looking at this last box right here today. There's my last box. What fraction of this box is empty? Well, it looks like half of it is filled, right? Because I have 2 cupcakes, and then I have this empty spot and this empty spot. So I have 2 out of 4 spots that are empty. And I can simplify that to 1/2 of the box is empty. And then if I'm looking at the next question, how many more cupcakes are needed to fill this box? Well, I can count that I need 1, 2. I need 2 more cupcakes to fill the box. So we already drew our model for this, which is helpful because then we're able to solve that second problem. So today we're continuing to practice how division and fractions are related, because sometimes you're going to get problems that are division problems, but we're going to get fractional answers, and that's how we're going to connect them together.